Okay, so title it logs. And I'm going to start with the actual definition of a log. Okay, and remember, we've already talked about it a little bit. When you're finding a log, you're finding the exponent, right? We're used to us asking 3 squared, and you give me the answer 9. Well, now I'm going to say 3 to what power gives me 9, and you're looking for the 2. That's all that logs are, okay? So a logarithm is the exponent to which a specific base is raised to obtain a given value. So guys, a logarithm is an exponent, okay? And I'm going to teach you how to go from logarithm to exponential and from exponential to logarithm. We're going to go back and forth. Okay, so to start off, okay, if I give you, we're going to have 2 columns. The first column is going to say exponential. And then we have a logarithm form. So what we've studied in the past is I would give you something like this. I would say, all right guys, 3 squared, and you would tell me the answer is 9. Correct? But in log form, okay, you write it with the same base. So what's the base of this problem right here? 3. So we're going to say, okay, I want to log with a base of 3. Correct? Okay? In other words, and then I know normally in exponential that's my answer, but here I'm going to say n 9. So how do I get from 3 with a base 3 to the answer of 9? How do I get from 3 to 9? What's my log? What's my answer?
Equals 2.
I equal 2. Right, you have 2, so that's log form. Now, guys, those of you that are more visual, watch or you want to understand this. Sometimes people call this circle math. And you start here at 3, you go through the answer and land back at the exponent. And that's the order you write things down in, if you like to look at it that way better. So I'm going to say log base 3, there's my 3. Then I wrote the 9 down, and a log is always an exponent. So the answer is the 2. Okay, so now let's try another one. What if I said 3 to the 5th power, I'm going to write it in exponential form, equals 243. That's an exponent. Okay, and for this part, there's no calculators. You won't use calculators today, right? So for here, you're going to write it the other way. You're going to say, write it in log form. So a log with the same base as your exponential. So what's my base again? 3 again. Okay. My answer is the 5. So I can't put the 5 yet, right? In a log, the answer is the exponent. So you're going to have to put the 243. And a lot of times you'll be given a problem just like this. And in your head, all that you're being asked to do, we just don't see this form very often, is 3 to what power is 243? Well, 3 to the 5th power, so it equals 5. Okay? If you like circle math, you can start with 3, go through 243 and land at 5. Okay, another one. 10 to the 4th power equals 10,000. That would be exponential form. We're going to write it in log form. We're going to say a log with a base of 10, right? You do circle math. I'm going to get to 10,000. In other words, how do I get 10 to what power gives me 10,000? Okay, and the answer is 4. It's kind of when you first study division, how your teacher tells you it's kind of the inverse of multiplication, right? If 3 times 4 is 12, and 12 divided by 4 is 3. It's the same here, okay? Now this one, 6 to the negative 1, and we did this on the warm-up. What is 6 to the negative 1 power, guys? It means 6 belongs in the denominator. So in log form, we're going to say log, going to start at the 6, right? Same base. Base 6, go through the answer and land at the negative 1. So log base 6 to 1/6. If that's all you saw in a problem, you're going to say, how do I get from 6 to 1/6? Well, how do I get from 6 to 6? With an exponent of 1. Well, if I want the 6 in the denominator, then the exponent is actually negative 1. Okay, now here's one with the variable. A to the b power equals c. You can try writing it in log form. So you're going to have log, same base, so base A. You can do circle math through c and land on b, so c. So a to what power gives me c, and the exponent is b. So a log means you're finding the exponent to get from a base to an answer. And here's another. What if I gave you 3 to the negative 2 equals 1/9? Pretty soon I'm going to take away the answers. You're going to find them on your own, right? I'm just making you convert from one form to the other. So this is going to be log base 3 to the 1/9. Now I know you know the answer, but let's look at this. I'm going from a whole number, base of 3, to an answer of a fraction. So the exponent has to be what? A negative. Well, how do I get from 3 to 9? What do you have to do to get from 3 to 9? Square it. So 3 squared is 9. So if I want the 9 to be in the denominator, I'm going to use the negative 2. Okay, sort of. Now then we're going to go the other way. Okay, I'm going to give it to you in log form, and you're going to write an exponential. So if I give you this, I'm going to give you the right side now. So 9 to the first power equals 9. Oh, did I do it backwards? I'm sorry, guys. I think by now I'll be more awake. I've been here all day. 9 to the negative 1 equals 9. I'm going to give it to you in exponential. I still did it wrong. Sorry. Okay. Third time's a charm. If I write that, you try to put it in exponential. I'm sorry. Okay, it's again with the circle math, right? The base of the log is going to be the base of your exponential. But if you go this way, right, the answer is the exponent, right? The answer to the log is the exponent. So 9, 1, and then the 9 here is the answer. 9 to the first power is 9. Let's try the next one. Log base 2 of 512 equals 9. Can you write that in exponential? I mean, you already have the answer. I just want you to go from one form to the other. That's all we're practicing right now. So the base of this log is going to be the base of your exponential. You're going to go 2 to the 9th power equals how much? 512. Okay. Now this one I'm not going to give you an answer. Let's just say an x here. It's going to be 8 to the x power equals 2. Now just some common sense here. 8 to the first power is 8. So what do we know about x here? It's less than what? 1. Less than 1. Log base 4, I'm just going to x in a different spot this time. Okay, so then this would be 4 to the negative 2 equals x. Can we actually solve that this time? So what is it? So 4 to the negative 2 is how much? 1 over 16. Okay. All right, so now that you can convert one form to the other, let's actually do some solving of the problems. So the first set of directions are just going to say evaluate. If I told you that log base 4 so in your head, what I'm actually asking you, and if you feel better about setting it equal to x, you can, okay? But it didn't say solve for x. This, you should just kind of look at this. Like if I said what's 2 times 3, you're gonna say 6. That's the same as this, okay? So, but what I'm technically saying is 4 to what power gets me 64? In other words, how am I getting from 4 to 64? What exponent gets me from 4 to 64? What goes in that circle there? So you may know?
3.
Right, 3. So the answer is just 3. Let's try number 2. What if I said log of a base of 1/4, 16? In other words, 1/4 to what power gets me to 16? That's what log means. How am I getting from 1/4 to 16? You may want to try.
1/2.
1/2. Okay, anybody else got any ideas? I'm going from a fraction to a whole number. So what does it mean my exponent is? So if I'm saying 1/4 to some power gives me 16. That's what I'm asking you. So I'm trying to get from a fraction. How do I get from 4 to 16 if it wasn't a fraction? 4 squared, right? So if I square 1/4, I'm going to get 1 over 16. But I don't want the 16 to be on the bottom. I want it to be on top, correct? So the answer is just negative 2. 4 squared is 16. Okay, number 3. Log base 2 of 1/16. Log base 2. So what exponent is going to get me from 2 to 1/16? Now, I'm going, and if you want to put a little x there and do circle math to think about it, 2 to what power is 1/16? But it doesn't really help you much, I don't think, because I'm trying to get from 2 to 16. I know it's going to be negative, because I'm going from a whole number to a fraction. Well, 2 to what power gets me just plain old 16? 4, but this time the 16 on the bottom, so what are we going to write? Negative 4. So to get from 2 to 1/16, my exponent is negative 4. Okay, let's try another one. Number 4. What if I gave you log base 27/9? This is where it gets weird. This one kind of starts to get star. Can I get from 27 to 9? I know 27 to the first power is 27, so I know it's going to be less than 1. It's a fraction. Now, you remember me earlier talking about, and if you guys are watching the video, you didn't see this part, but I told you that if you have this, okay, that if the bases are the same, okay, then that means that the exponents of those bases are equal, which makes sense, because this would mean that 3 squared equals 3 squared, and that's true. So what I've got here, if I set this equal to x, I'm going to say that 27 to the x power is 9. And I've got to come up with x. Remember me talking about in division over here on the board, how that when you divide, when you first learn 15 divided by 3 is 5, they're really simple. And the more you do, the harder they get. And even though we can do this, it's hard. Well, this is one of those that, this would kind of like being divided by 3.7. It's not too bad. So let me show you how to do this one. You don't need a calculator to actually do this. And what the goal is, when you can't get there in your head, you want to turn them into problems that have the same base. Okay? How can I get to 9 and 27? What base is going to get me to 9 and 27? Base 3. Okay? So you're going to rewrite 9 and 27 using base 3. So this would be 3 squared. Correct? Okay, now 27 is 3 cubed. So I'm going to write in parentheses here, I want 3 cubed, because that's the same as 27. I just replaced 27 with 3 cubed. But what's still up there? Don't forget about the x, right? I don't know the answer still. Okay? Now, remember me telling you that when the bases are the same, the exponents are equal to each other, correct? Well, the exponent on the left side, remember your rules on exponents. When you raise the power of exponents, what operation is that? Multiplication. So on this side, we have a 3x, and on this side, the right side, we have a 2. Correct? So when the bases are the same, they go away. And you can just say, now then that means that 3x equals 2. So what does x equal, guys? 2/3. Okay, now, go back and listen to me for just a second and let me walk you that circle one more time. Okay, watch. This was my original problem highlighted. I said 27 to some power gives me 9. Agree? I know it's less than 1. You and I just did the problem and we said 27 to the 2/3 power. Now let's take that piece of information back to a test we had a while ago. And remember me talking about this being power over root? Right? And I told you take the root first. So the cube root of 27 is what? 3, and 3 squared is 9. So it works. We just went the other way with it. Okay? All right, let's try number 5. Let's do log base 16 to the 8th. This is the same type of problem. You can set equal to x if you want. But let's think about this. I'm saying 16 to some power is going to give me 8. We don't know what. 16 to some power gives me 8. Okay, no calculators. Can we do it in our head? No, right? So we're going to write them with like bases, remember? How can I get to 16 and 8 with what base? 2, correct. So this is 2 cubed, agree? Isn't that 8? And 16 is 2 to the what? What's 16? 2 to the 4th. So I rewrote 16 as 2 to the 4th, but don't forget the x up there. That's what my goal is, to find x. Okay, now then the bases here are the same. So because on the left side, my exponents are 4. If the bases are the same, exponents are equal. So on the left side, that means that 4x equals, on the right side, 3. So x is what? 3/4. So in other words, 16 to the 3/4 power, you guys, is 8. That's what I'm saying. And you can check it. The 4th root of 16 is 2, and 2 cubed is 8. Okay, number 6. Log, this one's really easy. Log base 9 of 9 to the 5th power. This one's almost so easy that you're not going to be sure if the answer is right. Try it. What's the answer?
5.
Yeah. 9 to what power gives me 9 to the 5th? 5, right? Okay, or you can write it out if you want. 9 to the x power gives me 9 to the 5th. The base is max, so x is 5. Right? Okay, so you're feeling a little more comfortable with it. So of course now we're going to throw a little wrench in it. These two get stars because they're really weird. Number 7, log base 3 of 3 root 3. So my question to you is, how am I going to get what exponent, what crazy exponent, is going to get me from 3 to 3 root 3? Okay, when it doesn't work, what did I tell you to do? Write everything with the same what? Base, good. So there's a common theme going on here, right? So this is what it means. 3 to some power equals 3 root 3. So if I write everything with the same base, let's try it. Well, I can't write 3 to the x any other way. So I'm going to leave 3 to the x the way it is. This is the same as 3 to the 1st power. We're good with that, right? And how do I write the square root of 3? 3 to the what power? We talked about this in the warm-up. 3, this is the same thing as 3 to the 1/2 power over root. Okay? So let's clean up the right side. Do you remember what you're supposed to do? When bases are the same, what do? You add exponents, right? If bases are the same, you add exponents. So on the left side, I've got 3 to the x. On the right side, what's 1 plus 1/2? 3 halves, 1 1/2. So 3 to the 3 halves. Now the bases match, so what's the answer? 3 halves. Okay, can y'all look at this with me for a second? For those of you that want to process it, look. So what I just told you is that 3 to the 3 halves is the same thing as 3 root 3. Correct? Okay, remember doing this when I said power over root? This would be 3 to the 3rd power of the square root, wouldn't it? And remember how we would have to simplify it? Because this is the same thing as 3 squared times 3. We pull a 3 out and leave that inside. Okay, so it's just the reverse. Okay, now then, number 8. Log base 6 of the cube root of 36. How am I going to get from 6 to the cube root of 36? So you're going to go this way. 6 to what power gets me the cube root of 36? When we can't do it, what's the trick I told you? Use the common what? Common, same thing, yeah, the common base. Okay? Is there any other way to write 6? No, 2 squared, nothing works. So we're going to leave the 6 alone. So 6 to the x. Okay? Now, when you get to 36, this is the same thing as 36 to the what power? 1 over 3. Right? Okay, so now I have 36 raised to the 1/3. Okay, can I rewrite 36? What is 36 the same as?
6 squared.
So 6 to the x is the same as 6 squared. What are we gonna forget? The answer's not 2. What are we not gonna forget up there? 1/3. So on the bases match, so they go away. So on the left side I have x. What do I have up here on this right side? Raise to the power means you multiply. So 2 times 1/3 is 2/3. Okay, and you can check it. 6 to the 2/3 power, right? Power over root, that's a cube root of 6 squared. Isn't it? Power over root. So 6 squared, which is the same as 3/36. Same thing. Okay. Alright, I think I have like 2 more that are just kind of a little different. I don't want to leave you without doing them. Try this one. 9, 10, and 11. We have 3 more. Try those 2, and then I'll give you your last one. I'll give you a second or 2 to try it.